A very good morning, class. So as you all know, we have already started with lesson number 7, assignment and sequencing. We are focusing on the topic assignment problems by Hungarian method. We are focusing right now on minimization problems, and out of that we have already finished the 3 types. That is number 1 balanced, second unbalanced, and the third restricted. Now today class, our focus will be on a very important sum that is based on when the number of lines which we draw to cover the zeros are not equal to the rows and columns. Also, we'll be seeing sum wherein there exists more than one solution. That is, there is existence of an alternate solution. So let us start the sum class. Pay attention. So here is the example based on category 1, minimization problems, when the number of lines are not equal to the number of rows and columns. This is a sum from your textbook class. You have to solve the following assignment problem for minimization. So before we start the sum, let's do the basic check. Are the number of rows and the number of columns equal? Yes. Also, what is the objective function? So the objective function here is minimization. So the first step will be to convert it in row minimization. Now, as you all know how to convert it into row minimization, you will be picking minimum elements from each row and subtracting it from the particular elements of that row. For example, in the first row, you have the minimum number 80. Which will be subtracted from the remaining 4 numbers and from itself as well. Similarly, in the second row, you get another 80. In the third row, you have the minimum number to be 20. In the fourth row, you have the minimum number as 80. And in the fifth row, again, you have the minimum number to be as 80. So after subtracting, you will get a matrix like this. Now the next step will be converting in column minimization. So class, before we move on to the next step, check whether in each column what is the minimum number. Now as you can see in first, second, third and fourth columns, the minimum numbers are zeros. But what about the fifth column? Here you can see the minimum number is none other than 1. So the fifth column will be subtracting 1 from all the elements in the fifth column. So the matrix which you'll be getting will be like this. So I hope up till here the sum is clear. Now as I told you, before we move on to drawing the lines, check whether in each row you have a particular zero. At least one zero should be there. So we have done the checking and we saw that in each row and each column there is at least a single zero. So we can move on to the next step, that is drawing the required lines. So for that we need to copy paste the column matrix like this. Now for drawing the lines, you have to keep the logic in mind that you have to cover maximum zeros with minimum number of lines. So let us see first row wise what options do we have. So in the first, second, third and fifth row you have single zero. Whereas in the fourth row you can see there are 2 zeros which can be covered by a single line. So the first line will be drawn on the fourth row. Now coming to column wise. In the first column you can see there are 2 zeros. In the third column you have 1 zero. And in the fourth again you have a single zero. So we can cover 2 zeros by drawing a single line like this. Now again if you'll see, in row I have 1 zero. In the third row also I have 1 zero. In the same way in the third and fourth column too I have a single zeros. So you can either draw sleeping lines or you can draw standing lines because there's a tie. What is your observation class? Are the number of lines equal to the number of rows and columns? No. So in this case, our sum will move on to a new direction. Since the number of lines are not equal to the rows and columns, we are getting three types of elements. Now listen to this part very carefully. Numbers like 6, 1, 2, 4, 4, 5, 4, 2 are called as open elements because these can be seen clearly. Similarly, numbers like 0, 3, 2, 0, 3, 3, 0, 1, 2, 0, 3, 1, 0, 0 are called as closed elements because they are covered by a light. Now, as you all paid attention, I didn't call out the numbers like 1, 2, and 2. Now, the reason behind these is these three elements are called as intersecting elements. The reason being, both the lines sleeping and standing are intersecting on these particular numbers. So that is why whenever your number of lines are not equal to the rows and columns, you will always get three numbers. Three elements. Sorry for the mistake. The three elements will be open, which you can see, close, on which the lines are drawn, and third, intersecting, wherein the lines intersect the numbers. Now class, what is the next step? Whenever you come across such things, you should always pick up the minimum number from the open elements. Now observe and tell me class, what can be the minimum number from the open elements? Yes, you are correct. The minimum number here is 1. Now what to do with this particular 1? You have to subtract this particular 1 from all the open elements, and you have to add this particular 1 on the intersecting elements. I repeat it again. This 1 will be subtracted from all the open elements and added on all the intersecting elements. Whereas all the closed elements will be the same. Nothing will change for closed elements. So basically, as you can see, the green lines represent the numbers by which 1 will be subtracted. And the circle ones shows the position where 1 will be added. So I hope the concept is clear. Before you all start with the matrix, you have to write all these dialogues which you can see. So the next step is step number 4. Since the number of lines is not equal to the number of rows and columns, we get three elements: open, close, and intersecting. 1 is the minimum number out of the open elements. So we have to subtract 1 from all the open elements and add 1 on all the intersecting elements. So the new matrix will be like this. So as you can see, these three numbers have already changed because I added 1 over here. As far as 1, 2, 3, 1, 2, 3, 4 numbers, these also have changed. And the remaining numbers on which only there was a single line are one and the same. So I hope this particular step is clear. Now again, we'll be drawing the lines to see whether we are getting the final answer or not. So again, we'll be covering maximum zeros by drawing minimum lines. So as you all can see, in first row there are 2 zeros, and in the fourth rows also there are 2 zeros. So I can draw 2 lines like this. Now as far as the column is concerned, you can see there is a single zero in the first column, single zero in the third column, and single zero in the fourth column. So in this way class, I can draw the remaining lines like this. Now what is your observation? As you can see class, the number of lines here are 5. That is, they are exactly equal to the number of rows and columns. So what could be the next step? Correct. It is, we can start allocating the jobs. So moving forward with the next, since the number of lines is equal to the number of rows and columns, we can allocate the jobs as below. For allocating the jobs, you need a single zero. Now, as you can see class, in the first row, there are 2 zeros. So I will not do any allocation in that particular row. In the second row, you can see that there is a single zero, so I will put a first box over there. Simultaneously, if there is any zero in that particular column, I should cancel it. Similarly, in the third row, you can see there's a single zero. So I will put that in a box. And as you can see in that particular column, you can see one zero, which I should cancel. In the fourth row, there are two zeros, so you will not allocate any jobs to them. In the fifth row, there's a single zero, so you will put a box again. And simultaneously, you will cancel the zero in that particular column. Now we have finished the allocation row-wise. So now we'll go column-wise. So in the first column, as you can see, there is already a job which is allotted. In the second column, you can see that there is a single zero. So I'll put that zero in a box. And simultaneously, I will cancel the zero in that particular row. But class, what is your observation? Now you can see only 4 jobs are allotted and 1 job is still remaining. So that means if apart from getting lines equal, it is not compulsory that we will get the perfect allocation for the jobs. That means we have to again start with the procedure which I taught you all just now. So again we'll be starting with the same thing, that is finding the minimum numbers from the open elements, subtracting it from the open elements and adding it on the intersecting element. Since the number of allocation is not equal to the number of rows and columns, we again get 3 elements, open, close and intersecting elements. So once again, if we go through the matrix, 1 will be the minimum number in the open elements. So we'll be subtracting 1 from the open elements and adding it to the intersecting elements. So this was the matrix which we started, but we did not get the allocation. The number of lines was drawn like this. So in this case, particular class, 3, 3, 3, 3, 2, 1 are the open elements. So over here, 1 is the minimum number which will be subtracted from all the open elements and added basically on intersecting elements. So the green lines represent the numbers from which the 1 will be subtracted and the zeros represent the places wherein 1 will be added. So again we are drawing a new matrix which will look like this. So class, I have subtracted 1 and I have added 1 to the respective positions which I explained you all just now. Now before drawing lines, always check class whether you have 0 in each row as well as in each column. Now what is your observation class? Each row and each column is having a 0 only except the first row. Can you all see in the first row there is no 0 left? So your first step will be to convert again in row minimization by subtracting 1 from that particular row. So converting it again in row minimization by just changing the first row because there was no 0 left. And for drawing the lines, the minimum requirement is there should be at least 1 0 in each row and each column. So now the condition is satisfied and now we can draw the lines as follows. So class, tell me on which rows first you will draw the lines. Correct. So on the first row, on the fourth row and on the fifth row. These 3 are having 2 zeros each, which can be covered by drawing 3 lines. Now, as far as the columns are concerned, there are only 1 0 in column number 3 and column number 4. Now, let us see how many lines we are getting. So, we have got 5 lines over here. So, we can go with the next step, that is allocation of the jobs. So as the number of lines are equal to the rows and columns, we can start with the allocation of jobs like this. The allocation starts from a single 0, which is there in second row. So I put that 0 in a box. Similarly, I can see 1 0 in the third row, And at the same time, I will cancel the 0 in that particular column. In row 4, again, there are 2 zeros which I will not allocate right now. In the 5th column, again, you all can see that there are 2 zeros, so I will leave it and I will not allocate it right now. Now I will go column wise. So in the first column, as you all see, there are 2 zeros, so I am not allocating it right now. In the second column, you can see that there's a single 0, so I will allot that particular 0 a box. And simultaneously, I will cancel the 0 in that particular row. In the 3rd and 4th column, the jobs are already allotted. In the 5th column, because of this 0 being cancelled, I am left with 1 0 which I can put it in a box. And simultaneously, I can cancel the 0 of that particular row. And I'm left with only a single 0 at the topmost position, so I will assign it a particular job. So class, now what is your observation? So the observation is each particular person is having each particular job. So that means my final answer is finally coming around. So there were 5 operators and each operator has got a machine assigned. So the first operator got the first machine, the second got 4th machine, the third got the 3rd one, 4th got the 2nd one, and 5th got the 5th one. So this was the question class. We had to find the problem for minimization of time. And this was the solution which we derived just now. So we can compare and find out the total minimum values. So as you can see, the first number here is 18. The 4th number here is also 18. The 3rd number over here is 20. The 2nd number over here is 18. And the last number over here is 21. So on adding together all the 5 numbers, I've got the answer to be as 95 units. So I hope class, the procedure which you saw is a bit lengthy. But yes, once you are clear with the concept, then it will become very easy and you will love doing the sums. Now don't worry class, I have got another example for you which includes the same pattern of which we covered just now, that is when the lines are not equal to the rows and columns. Plus, in this sum there exists an alternate solution. That means the final answer will remain the same, but there will be different more than one particular assignment which you can opt for. That will not change your final optimum solution. So let's have a look. A company has 4 jobs. The following matrix shows the cost of assigning each job to each machine. How should the jobs be assigned to the machines to minimize the total cost? So this is your question class. I'm giving you 2 minutes to observe the question. While observing, check for the basic conditions which I told you. The rows should be equal to the columns. And second, check your objective function, whether it is minimization or maximization. So I hope you all have checked the basic conditions and both are satisfying. So we can move on to the first step, that is converging in row minimization. So as you all know class, row minimization is you will be picking each minimum number from each particular rows, J1, J2, J3 and J4. And after subtraction, you will get a matrix like this. Now, we start with column minimization. So for column minimization class, you have to see minimum numbers from each particular columns, M1, M2, M3, M4. Now in the first column, all the 4 numbers are minimum. But what about second, third and fourth column? So here in the second column, the minimum number is 6. In M3, the minimum number is 12. And in M4, the minimum numbers are 18. So you will be subtracting all these numbers from these particular columns and you will get a matrix like this. So I hope the concept is clear up till here. Before we draw the lines, always check class whether in each row and in each column there should be at least one zero. So the condition is satisfied. So moving forward with the next concept of drawing the required lines. The concept is covering maximum zeros by drawing minimum lines. So tell me class, which row has got the maximum zeros? Or you can opt here and you can see that if I go row wise, I can cover the last row which has got 3 zeros. So the first line I will draw is on the 3 zeros. Then in the first column you have got 3 zeros and in the last column you have 2 zeros. So the first line I will draw on the first column. Now class, if I see row wise, there is one single zero in J2 and one single zero in J3. But at the same time, if I see in the fourth column, I can see two zeros which can be covered by a single line. So my third line will be drawn on the fourth column. Now what is your observation class? The number of lines drawn over here do not match with the number of rows and columns. That means you are getting three elements: open, close, and intersecting. So what should be the next step, class? Correct. Identify the minimum number from the open elements, which I guess you have identified up till now. And that was number 2. So you have to subtract 2 from all the open elements and add it to the intersecting elements. So as you all can see, class, this was the matrix. 2 is the minimum number, which will be subtracted from the lines which I have marked as green and added on the circles which are the intersecting elements. So the new matrix in front of you will be like this. So after subtraction, you see these numbers have changed and these two numbers have also changed. Now we can draw the line, but before that, check class in each row and each column, there should be at least one zero. So the condition is satisfied. So now we can draw the lines like this. Now tell me class, on which rows you will draw the lines first? Correct. On the second and the third row. Now you can see, if I go column wise, I can see 1 0 over here. But in the row wise, I can see 2 zeros over here. So I can draw the third line in the fourth row and a single line in the first column. So class, now compare the number of lines which you have drawn in the matrix with the rows and columns. What is your observation? Correct. The number of lines is equal to the number of rows and columns. So you can allocate the job as follows. What was the technique I taught you all, class? Starting with a single zero. So as you can see in the first row, you have a single zero. I will put that in a box and simultaneously I will cancel the zero in that particular column. Coming to the second row, there are two zeros, so you will leave the allocation right now. In the third row as well, there are two zeros, so you will not allocate any allocation to it. In the fourth one, again, you can see there are two zeros, so you will not allocate the allocation right now. The rows are over. Now we can move to the columns. In the first column, there's already an allocation done. In the second column, there are three zeros. For the time being, I will not do any allocation in that particular column. In the third column, you can see there is a single zero. So I will assign that zero a job. And simultaneously, I will cancel the zero in that particular row. In the last column, you have two zeros, so we'll not give any assignment to it right now. Again, we'll check row wise. So in J2, there are two zeros. In J3, there are two zeros. In M2, there are two zeros. In M4, there are two zeros. So whether you go row wise or you go column wise, class, you are having a choice, an option to select any zero from the four available. So class, where you have got a choice and where you get an option to select the zero, that particular sum has got an alternate solution. So consider if I put this 0 in the box, the corresponding 0 in the row will get cancelled as well as in the column it can get cancelled. Now one box can be there in a single row and single column. So I cannot allocate this 0. So I can put this 0 in a box so that the simultaneous 0 above it can get cancelled. So as you can see class, I have got all the 4 allocations done. This is the first type of option which you can do. The second type is the allocation in the start remains the same just as this. So these 2 allocations were very clear, but now you have got a choice. Some people can also select the third 0 and cancel the 0 above, and same way you can consider the second 0 over there and cancel the 0 below it. So these are your 2 alternate solutions, and if you do any one out of this, both will be considered as correct. So I hope the logic is clear. In each row and each column, you can have only one allocation. You cannot repeat the boxes, or you cannot have 2 boxes in one row or in one column. So while allocation, keep this thing in mind. So as per first possibility, this is the allocation which you can give. And as per the second possibility, this is the allocation which you can give. The only difference is between J2 and J3, second and fourth, or fourth and second. When I go to the final answer, the answer will be the same. Now the answer I'm showing you all with respect to the first one. For this allocation, the total minimum cost comes to 40 plus 38 plus 43 plus 51, which gives me 172 rupees. As far as the second assignment is concerned, if I add the second possibility as well, that is 40 plus 48 plus 33 plus 51, I get the same minimum cost of 172. So this case is referred to as case of an alternate solution. So I hope class the concept is clear. Please listen to the video more than once in order to understand the steps of how to do the sums, which involves alternate solution, and when the number of lines you draw are not equal to the rows and columns. So for that, I am giving you all 2 to 3 sums for practice, which I think you can practice and see whether you have followed the concept or not. The first sum is like this. Find optimum assignment for the following problem. The second one here shows how should the horses be allotted to the riders so as to minimize the expected loss of the team. Apart from these two, you can also solve sum number 2 of your exercise 7.1. So class, with this, our first category, that is minimization problems, are completed over here. From tomorrow onwards, we'll be starting with the second category of sums. The topics will be the same, but the only difference will be instead of minimization, our objective function will be changed to maximization problems. And as in the same way, we'll be covering all the 5 topics, that is balanced and maximization, unbalanced and maximization, restricted and maximization, alternate solution and maximization, and number of lines are not equal to the rows and columns with maximization problems. So till then class, clear the concept of minimization problems by solving it with Hungarian method. Thank you so much for listening to me, and we'll continue with the maximization problems tomorrow. Till then, stay safe, keep healthy, keep studying, keep practicing. Thank you so much, class.